Hi friends, welcome back to Sea Level Physics. My name is Srinivas. Today's topic is acceleration versus time graph. Okay, what is meant by acceleration? When a particle is under motion such that its speed either increasing or decreasing, there is some acceleration. If speed is increasing, that is positive acceleration. If speed is decreasing, that is negative acceleration, also known as deceleration or retardation. Okay, now let us see the graph between acceleration and time. Okay. Here, acceleration is taken along y-axis and time is taken along x-axis. Okay. Now, variation of a with the time is as shown. See, straight line. If I find slope somewhere here, say somewhere here theta. Okay, what is that theta? Slope angle. Now, what is the opposite side? That is change in acceleration, dA. Now, what is the adjacent side? That is, what is the adjacent side? Interval, that is dt. Right? Now, slope is slope equal to change in y coordinate by change in x coordinate. That is slope equal to dA by dt. What is a? Change in velocity per time. But what is dA by dt? Change in acceleration per time. Means the rate of change of acceleration. Here, acceleration is not at all constant, changing. Right? In fact, acceleration means rate of change of velocity. But the rate of change of velocity also changes with time. That is change in acceleration per time. So it represents a new quantity, that is, what is that quantity? Jerk. Right? J-E-R-K, jerk. Means the rate of change of acceleration. So what is that quantity? Jerk. What are the units for jerk here? Acceleration per time means acceleration meter per second square divided by time, that is second. That is equal to meter per second cube. Okay, meter per second cube are the SIs per quantity jerk. What is jerk? The rate of change of acceleration. When a particle is moving such that its acceleration changes, it possesses a new quantity, that is what? Jerk. Am I right? Now, let us see the product of y coordinate and x coordinate. What is y coordinate? A, acceleration. What is x coordinate? Time, t, right? That is y into x, that is equal to a into t. Let us check, is there any significance by doing like that or not? Okay. Now, what are the units for acceleration? Meter per second square. Meter per second square into time into second. Time in second. So meter per second square into second means second cancel. We left with the meter per second. Okay. What is meter per second? What is that unit? That is the unit of velocity. Am I right? So there is significance by taking product acceleration into time. Means the area of acceleration versus time graph represents one quantity. What is that quantity? What are the units of that quantity? Meter per second means in fact velocity, but it is not velocity, change in velocity. Why? Because area equal to change in velocity. Change in velocity, that is delta v, that is v minus u, otherwise final velocity minus initial velocity. Why? Because at means we know that one of the kinematic equations, what is that? V equal to u plus a. V equal to u plus a. Since v equal to u plus at, what is at? V minus u implies at equal to v minus u, that is delta v. Change in velocity. See the product here, y coordinate multiplied by x coordinate, that is a into t, right, representing one quantity having unit meter per second. In fact, that is the unit of velocity. Strictly speaking, it's not velocity, that is change in velocity. Why? Because v equal to u plus at, that is at equal to v minus u. V minus u means change in velocity. So what does it represent? The area of at curve means the change in velocity. It's not velocity, that is change in velocity. Okay, right? Now, let us see one example that appeared in 2004 2004 IIT screen. Right? Very simple example. What is that example means? If following is the AT graph for a particle which starts from rest find its maximum velocity. Alright, so this is the given question. Here we have one graph from data. What is that graph? See, acceleration versus time. It is acceleration A in meter per second square, time in seconds. So a given graph is like that. So here maximum acceleration at t equal 0. What is that value? 10 meter per second square. 10 meter per second square at t equal 0. What is the maximum acceleration? 10 meter per second square. Now acceleration decreasing at a constant rate and becomes 0 somewhere here at 11 seconds. So very simple question. This is the given graph for a particle which moves along a straight line with a 0 initial velocity. Now we need to find maximum velocity acquired by the particle. One hint is there. What is that hint? Particle starts from rest. In the sense u equal to 0. Right? U equal to 0. Now itself we came across one point, that is area of AT graph equal to change in velocity. So here we need to find area of the graph. So area of the graph. What does it represent? Area of the graph equal to delta V. So delta V equal to V minus U, that equal to area of AT graph. Right? Area of AT graph. Right? That is, what is that area? V minus U means what? Starts from rest in the sense initial velocity 0 equal to area means half into base into height. See, this is the area. So we need to find area between AT graph and time axis. So this is the area. What is the shape here? Triangle. So area means half into base into height. So here U equal 0. Here V becomes maximum velocity. So V max equal to half into base means 11 seconds into height means 10 meter per second square. That equal to V max equal 10 11 jar 120 by 2, that is 55 meter per second. So this is what? Maximum velocity. Okay. Now let us see one more sum. 2005 IIT screening. 2005 IIT screening. Right? 2005. So in 2005 IIT screening, one question is given like that. 2005 IIT screening, right? Okay. Now you are given velocity versus x graph, right? If following is the velocity versus x graph for a particle moving along straight line, convert Vx graph into Ax graph. A means acceleration, x means position, otherwise displacement. Convert Vx graph into Ax graph, right? Of course, 4 options also there, but I don't want to write options. Why? Because my intention is to minimize length of the video. Okay, right? So given graph is as follows. This is the given graph. Velocity versus x. Velocity versus x. So graph is like that. When x equal to 0, what is the max velocity? V0, right? Velocity decreasing at a constant rate from maximum value V0 and even becomes 0 at x0 also. When x becomes x0, velocity becomes 0, right? So this is what theta. Theta is greater than 90. Theta is greater than 90. That is obtuse angle. Means slope of this graph is negative, right? So slope is negative, right? What is the slope here? Change in y coordinate by change in x coordinate. So slope equal to here v0 by x0. v0 by x0. This is what slope, right? Now let us see what is the general form of this graph. If yx graph is like that, what is the general equation for that graph? Means y equal to, what is the general equation for this straight line? Y equal to, as slope is negative, y equal to minus mx plus c. This is the general equation. General equation, right? For the straight line. If it appears like that with the negative slope and lying above the positive x-axis and starts from max value and becomes 0 for particular x value, right? For this straight line, this is the general expression. Y equal to minus mx plus c is the general expression. What is y here? Velocity is y. So v equal to minus m means what? Slope means m. What is that value? v0 by x0. So v0 by x0. M means slope, right? v0 by x0 plus c. What is c? When x becomes 0, y becomes c. When x becomes 0, y becomes v0. So v0 is the c value. v0 is the c, right? C means what? Y interception provided at x equal to 0. So x becomes 0 means v becomes v0. So x becomes 0 means y equal to c. Here x becomes 0 means v becomes v0. So c equal to v0, right? This is the given form for vx graph, right? So v equal to minus v0 by x0 plus v0, right? That is dv by, here x also there, here x also there, minus m means v0 by x0 into x is there here, into x plus c means what? v0, right? So implies, if I differentiate with respect to position, that is dv by dx equal to minus dv by dx equal to minus v0 by x0 is constant. Why? Because slope is constant. Here slope is constant. Why? Because that is a straight line. So v0 by x0 constant. Negative sign is kept outside. v0 by x0 also constant. So dv by dx in the sense here minus v0 by x0 into dx by dx. That is 1. 1. So into 1. Plus here v0 is max value. This is also constant. So it becomes 0. So on differentiating, dv by dx equal to minus v0 by x0 into 1 plus 0 into 1. Why? Because d by dx of, otherwise write like that, d by dx of x plus d by dx of v0. So what is the ultimate answer here? dv by dx equal to minus v0 by x0 into dx by dx means 1, cancels. d by dx of v0 is 0 since v0 is constant, right? So we left with this one. dv by dx equal to minus v0 by x0, right? Now, what is acceleration? We have to express this graph into acceleration versus position graph. So what is meant by acceleration? Acceleration means we know that acceleration equal to, acceleration means v into dv by dx. This is what chain rule. we need to express the same graph into Ax graph, right? So acceleration in terms of x means that is A equal to V into dV by dx, chain rule. That is acceleration equal to V means what? This is what V, number 1. This is what number 2, right? V means substitute V from number 1, that is V equal to minus V naught by x naught into x plus V naught whole into dV by dx. dV by dx means what? Minus V naught by x naught. Minus V naught by x naught. Since from 1 and 2. Since from 1 and 2. Right? Since from 1 and 2. That is A equal to minus or minus plus V naught by x into V naught by x. That is V naught by x naught whole square into x. Right? Plus or minus V naught into V naught square by x. Right? So simply take my multiplication here, minus or minus plus V naught by x into V naught by x, that is on square into x, plus or minus V naught square by x. X naught. See, this is the expression for acceleration, right? Here V naught by x naught, that is slope, constant. Some constant whole square means again constant, right? Here V naught by x naught also constant into x naught V naught also constant. Therefore, what is this general expression? Y equal to mx minus c form. General form. This is the general form for acceleration. See, this is in the general form of y equal to mx minus c. Acceleration equal V naught by x naught whole square into x minus V naught square by x naught. See, this bracket term is constant, right? This is also constant, but x variable, a variable. So acceleration varies with the x like that, right? Which is in the form of y equal to mx minus c, right? Y equal to mx minus c. Y means what? Y means a. Y means a. Here x means x only. But the form is mx minus c form. Mx minus c means slope is positive, but when x becomes 0, y equal to minus c. When x becomes 0, a equal to minus value. So this is the graph. Right? See, slope is positive for this graph. Slope is positive. Here also slope is positive. What is that slope? V naught by x naught whole square. So slope equal to V naught by x naught whole square. Alright? Right. But c equal to V naught square by x naught. Y interception when x equal to 0, that is c. C equal to y interception when x equal to 0 is V naught square by x naught. So this value. Alright? Sorry, this value. Alright, this value is c. Alright? Slope is that one. So this is about conversion of Vx graph into Ax graph. Alright? Let us see one more numerical, that is 2012 May 12 occurred in mains, right? 2012 May 12 mains question. 2000 May 2012 May 12, right? Suppose a particle moves along straight line. The distance traveled by a particle moves along straight line is proportional to the distance covered by a particle moving along straight line, moving along straight line is proportional to TQ, is proportional to TQ. T means time, right? Means the distance traveled by that particle is directly proportional to TQ, right? Now express acceleration time graph, AT graph. Of course, 4 options are there. I don't want to write options. See, here distance is proportional to TQ. Particle moves along straight line such that its distance covered is directly proportional to time Q, right? But S equal to some constant K into T, right? As S is proportional to TQ, S equals some constant K into T, right? That is, on differentiating with respect to time, it will convert into velocity, right? That is a ds by dt equals some constant K into d by dt of TQ, right? ds by dt means velocity. That is equal to some constant K into d by dt of TQ means 3t square. Power into t power minus 1. That is 3t square. So, on differentiating again, dv by dt equal to 3k constant d by dt of t square. Alright, d by dt of t square. That is dv by dt means acceleration. Acceleration equal to 3k into d by dt of t square means 2t, right? That is a equal to 2 3 6k into t, 6k into t. That is 6k is constant again, a equal to some constant 6k into time. So what are variables here? Acceleration varies with the time, but 6k is constant. So it is in the form of y equal to mx, general form. The graph is like that. So acceleration is along y-axis, time is along x-axis. So y equal to mx means straight line passing through origin, right? Y equal to mx form, straight line passing through origin. So this is the required graph, right? Now let us see one more question that appeared in mains 2019 April 8, right? What is that question means? For a particle moves along straight line with constant acceleration, which starts from rest, Okay, for a particle moves along straight line with constant acceleration which starts from rest. Pick up correct options. So option 1, that is A, acceleration versus time graph. Option B, velocity versus time graph, right? Okay. Option C, position versus time graph, like that, right? Option D, also position versus time graph, right? Like. So this is the given question with the 4 options, right? Among those we have to pick up correct options here. See, what is data? Particle starts from rest and moves with constant acceleration along straight line, right? For the data, let us see correct options here. From the question itself, acceleration is constant. So there is no change in acceleration with respect to time. Say, as time goes on, acceleration constant. So option A is correct. So acceleration constant, right? Now option B, acceleration constant in the sense, A means what? A means what? Acceleration. That is V versus T, slope also acceleration, right? Here slope equal to dV by dt, alright? That is acceleration. Right? dV by dt is constant. Acceleration is constant in the sense dV by dt is constant. That is constant, right? And slope is constant. See, velocity versus time graph is straight line passing through origin. Here, slope is constant. Starts from rest means when t equal to 0, velocity becomes 0. So that is justified. Moreover, it moves with constant acceleration means the rate of change of speed with respect the rate of change of speed constant means speed increases at a constant rate. Velocity, acceleration constant in the sense speed increases at a constant rate, right? If I calculate slope here, that slope is constant all along its length. So this is also valid. So V versus T graph is straight line, means acceleration is constant. Acceleration constant. So this one also correct option. Option B also correct. Option A also correct. Right? Now let us see here. Option C, variation of position with respect to time. Here, the slope of xt graph is velocity. Right? Here see slope gradually decreasing means velocity gradually decreasing. Velocity here gradually decreasing. Dx by dt, that is velocity decreasing, means speed decreasing at a constant rate and even becomes 0 also here, right? Which is ruled out. Why? Because speed increasing at a constant rate from data. So this is what wrong option. So A is correct, B is correct. Now what about D? See, x versus t only here also, but slope increasing at a constant rate. See here, slope increasing at a constant rate. If I calculate slope here, theta 1, here theta 2. So theta 2 is greater than theta 1. Right? Tan theta 2 is greater than tan theta 1. That is, tan theta means what? Dx by dt. Means velocity. V2 is greater than V1. So as time goes on, speed increasing at a constant rate. Alright? That is dx by dt increasing at a constant rate. Means velocity increasing at a constant rate. Right? Acceleration is constant. Why? Because the graph is symmetrical, concave upwards. Position time graph is concave upwards. What is the inference? Acceleration is positive and speed increasing. Why? Because velocity positive here. Velocity positive. Acceleration also positive. Means speed increasing. Okay. Right? So option D also correct. Now let us see finally one more sum. General question but important model. Suppose particle moves on the x-axis whose position coordinate changes with the time as follows. That is x equal t minus 2 and t minus 3. See, for a particle moving on x-axis, its position changes with the time as x equal to t minus 2 into t minus 3. X equal t minus 2 and t minus 3, right? Now find the distance traveled in a time interval. In a time interval. In a time interval where it lies, where it is at origin. At origin. Right? See once again. For a particle moving on x-axis, its position changes with the time as x equal t minus 2 into t minus 3. So we need to find the distance traveled by that particle in a time interval when it is at origin. See, given variation of x with the time is x equal to t minus 2 into t minus 3. That is what? T into t square minus 3t minus 2t, that is minus 5t minus some minus plus 2 3 is 6. So this is what variation of position with the time is as follows: x equal t minus 2 into t minus 3 in the sense t square minus 5t plus 6 on extending, right? Now let us check what is the position of the particle at t equal to 0. So x at t equal to 0, that is equal to t equal to 0. Substitute here 0 minus 2 minus 2. 0 minus 3 minus 3 minus 2 into minus 3 means plus 6, right? Position at t equal to 0 means initial position plus 6. Whether it is centimeters or meters or millimeters, so we don't know. Plus 6 units as an example, right? Now position at x equal to position at t equal to 2. Let us check. Position at t equal to 2 seconds. 2 minus 2, 0. 0 into something, 0. That is 0. Means at time t equal to 2 seconds, position of the particle is 0. Similarly, position at t equal to 3 seconds, that is 3 seconds. 3 minus 2, that is 1. 1 into 3 minus 3, 0. 1 into 0, 0. That is 0. Right? So initially the position of particle is plus 6 units. At 2 seconds position is 0. At 3 seconds also 0. Right? At 2.5 seconds as an example, position at t equal to 2.5 seconds, that is 2.5. Substitute here 2.5 minus 2, that is 1 by 2. 1 by 2 into 2.5 minus 3, that is minus 1 by 2. Alright, once again, check here. Substitute t equal to 2.5, 2.5 minus 2, 0.5, that is 1 by 2. Into 2.5 minus 3, that is minus 0.5, that is minus 1 by 2. 1 by 2 into minus 1 by 2, that is minus 1 by 4. Minus 1 by 4 units. Right? Now what about velocity here? Velocity. Dx by velocity equal to dx by dt. X is t square minus 5t plus 6. Now on differentiating with respect to time, what will you get here? Dx by dt means, that is t square means 2t minus 5t means 5 plus 6 means 0. Why? Because 6 is constant. So on differentiating x with respect to time, we will get velocity, that is 2t minus 5. 2t minus 5. Velocity at t equal to 0 means initial velocity when it is lying at plus 6 units. What is that velocity at t equal to 0? That is when t equal to 0, 0 minus 5, that is minus 5 meters per second. Means moving towards negative x-axis, but lying at the positive side, right side of the origin, that is at a distance of plus 6 units, but moving towards negative x-axis. Alright? See here, this is the graph. For example, x equal to 0, here x equal to plus 6 when t equal to 0. Alright. When t equal to 0, what is the position of the particle? Plus 6. When t equal to 0, position is plus 6 units. Right? But initially moving towards negative x-axis. Why? Because velocity is minus 5 meters per second. So, of course, it is lying on right side of the origin, but moving towards negative x-axis. Like that. Now, at time t equal to 2 seconds, it reaches origin. Why? Because position coordinate 0 means origin. At time t equal to 2 seconds. Right? Reaches origin. Thereafter, at time t equal to 2.5 seconds, what is the position of the particle? Minus 1 by 4. See, minus 1 by 4. So, x equal to minus 1 by 4 at t equal to 2.5 seconds. Alright, at t equal to 2.5 seconds. Alright, at t equal to 3 seconds. Of course, if you substitute t equal to more than 2.5 and less than 3, suppose here more than t equal to more than 2.5 means 2.5 more than 2.5 means here suppose somewhere here in calculating velocity. If t equal to velocity at t equal to 2.5, substitute here 2 into 2.5, that is 5. 5 minus 5, 0. So this is what extreme position for that particle moving on the x-axis, either side of origin, right? When it reaches x equal minus 1 by 4 on the negative side of origin at t equal to 2.5 seconds, its velocity becomes 0. Here velocity becomes 0. Right? If t is greater than 2.5, suppose v at t is greater than 2.5. So 2 into greater than 2.5 means more than 5. More than 5 minus 5 means positive. That is positive. Alright? That is positive. Means retracing. Here particle retarding and comes to rest here at this extreme position and again retracing. Why? Because velocity is positive beyond 2.5 seconds. Means it starts to move towards positive x-axis. Initially, after crossing origin, it moves towards negative x-axis and again starts to retrace like that. Alright? Okay. So this is the situation. Right? From x equal to plus 6 to x equal to 0, x equal to 0 to x equal to minus 1 by 4, again from minus 1 by 4 to x equal to 0. Right? At t equal to 3 seconds. At t equal to 3 seconds, what is the position here? 0. So at t equal to 3 seconds, once again particle reaches to origin from extreme position. Right? From this extreme position, again particle reaches to origin here. Now, see the interval here. Initially, particle crosses the origin at t equal to 2 seconds. Right? Afterwards, at t equal to 2.5 seconds, it reaches negative extreme position. Afterwards, 3 seconds again, at the instant 3 seconds again, it retraces from negative extreme position to origin. So, particle appears twice at origin. Initially at t equal to 2 seconds and again at t equal to 3 seconds. So, in this interval, this is the path of the particle. Of course, retracing along the same path, I am dividing separately. So, t equal to 2 seconds once crossing the origin, again t equal to 3 seconds crossing the origin. Now, what is the distance covered from here to there? What is that distance? See, minus 1 by 4. Minus 1 by 4. At x equal to t.25 seconds, what is the distance covered? Right? At t equal to 0, what is the answer? X equal to 0. Right? But at t equal to 2.5 seconds, what is the position of the particle? Minus 1 by 4. So, this is what minus 1 by 4. Minus 1 by 4 plus minus 1 by 4. That is 1 by 2. In the time interval when it comes to origin. Right? That is the distance covered. So, total distance equal to, it is 1 by 4 See, this is what 1 by 4 meters. This one also 1 by 4 meters. So what is the distance here in the time interval when it comes to origin means first at a t equal 2 seconds, again at a t equal 3 seconds, right? So in the time interval it covers a distance of 1 by 4 plus 1 by 4. 1 by 4 plus 1 by 4. So total distance equal to 1 by 4 meters plus 1 by 4 meter. That is 1 by 2 meter. If it is in meters, right? Meters, for example. Okay. Now same can be realized as follows. See, this is the x, right? This is what time? X versus time. Like that. Graph is like that. See, at t equal to 0, what is the position of the particle? Plus 6. At t equal to 0, position is plus 6 meters, right? Now at x equal to x at t equal to 2 seconds, 0. So this is what 2 seconds. Position is 0, right? Now at x equal to 2.5 seconds, what is the position? Minus 1 by 4. See, this is what? Minus 1 by 4 at 2.5 seconds. At 2.5 seconds, position is minus 1 by 4, right? Okay. Now at at t equal to 3 seconds, what is the position again? 0. So this is what 3 seconds. At 3 seconds, position 0. At 2 seconds, position 0. At 2.5 seconds, position is minus 1 by 4. Now this is the interval from 2 seconds to 3 seconds. This is the interval from 2 seconds to 3 seconds, in which particle covering a distance of 1 by 4 plus 1 by 4, right? 1 by 4 plus 1 by 4. Why? Because it is moving towards negative x, again towards positive x. But as it is distance, no need to consider negative sign. Take with positive sign on. So 1 by 4 plus 1 by 4. Otherwise 1 by 4 plus 1 by 4. That is 1 by 2 meter. This is the required answer. Okay friends, with this I am concluding. Okay, thank you friends, all the best.